Hello everyone. In this lecture we are going to learn about transportation problem. In this lecture you are going to understand what is transportation problem, how the problem will be structured, and how to solve this transportation problem, and what are the various steps involved in this, and what are the stages of obtaining the solution for the transportation problem that we are going to learn under this in this lecture. Let us see the step-by-step procedure to solve this transportation problem. The main aim of the transportation problem is to minimize the cost of transporting the goods from the several sources. Generally, the transportation means from moving a product or the service or a vehicles from one place to the another place. Actually, in this transportation problem, when we are moving from the goods from one source to the another place, that means here in this example that I am going to take, we will have a different sources of the supply. From that point to the destinations, we call it as demand points. While satisfying the supply and the demand constraints, when we are solving this, what is our main aim is, main aim is to minimize the cost of the transportation. We will have a cost involved when we are moving the goods from one place to the another place. There will be a cost which will be involved. But when we are doing this sum, when we are applying the methods, we will try to minimize the cost of the transportation problems. Now, here I have taken an example along with the step-by-step procedure. Now, the formulation of the problem, generally how the problem will be formulated. Let us see this. In the problem, when we see that, in the next slide you are going to see how the structure will be. There will be the rows and the columns. The problem will come in this rows and columns, and in this the cell values also will be there, and the right side of the table you will find the supply values, and the down or the bottom you will find the demand values. Now here I have taken the example of the sources. As I said, the transportation problem aims to minimize the total transportation cost. Here the sources of the supply is the biryani outlets. There are some biryani outlets who are supplying the biryanis, or they are taking the orders. It's some XYZ company, and they have some destination. This destination we call it as places of demand, right? From the sources of supply to the places of demand when the goods are transporting. In our example, I have taken the biryani orders as an example. When they are delivering the orders from one place, source to the destination, there will be some cost which will be incurred in that. What is that cost? We are calling it as a cost per unit of transporting source to the destination. That values in the values which is written in the cell are the cost of transporting the good from one source to the another destination. Now the supply will see in the right side of the each row, and the demand in the bottom of the each column. Let us see how the problem will be. See, I have taken this example in this. Now this is the total transportation problem. There is a biryani outlet, that is some XYZ company. They have 3 outlets. One is in Madhapur, one is in Begumpet, one is in Hayat Nagar. 3 outlets, and they have 4 destination points. In another word, destination point means in this area this company is delivering the biryani, or they are taking the orders, and in this Amirpet the demand, the total number of orders demand they have is 30. In Kukatpalli the demand value is 40, and in Banjara Hills the demand is 50. In Secunderabad the demand is 30. Now, they have 3 outlets, as I said. From these 3 outlets, they need to transport these orders or these biryani orders from these places to these destinations. Right? They have 3 outlets. One is in Madhapur, Begumpet and Himayat Nagar. There are 4 destinations to transport. Now, if you observe what are these numbers, these are the transportation cost. For example, if they deliver a biryani order from Madhapur to Amirpet, O1, origin 1 or the outlet 1, destination 1 is the Amirpet, the cost is 5 rupees. Like the same way from Madhapur, if they are transporting that order from Madhapur to Kukatpalli, the cost is 8 rupees. Why is it? Like that it will come. 6 from Madhapur to Banjara Hills, from Madhapur to Secunderabad. If you take this 7, Himayat Nagar to Banjara Hills, these are all the costs which are incurred in, which will incurred in from transporting from the outlets to the destination points. Now our overall aim is to minimize the transportation cost. They have 3 outlets, they have, these are the demand values, and now what is the total demand value? I mean orders, number of orders, demand is in Amirpet, Kukatpalli, Banjarahills, Secunderabad, all together it is 150. They have estimated order, number of orders is 150. From these 3 outlets, how much they can supply is from Madhapur 50 orders they can supply, from Begumpet 60 they can supply, and Himayat Nagar they can supply 40. Right? All together the total supply they have is 150 and the total demand is 150. This is called satisfying the demand and supply constraints. The supply and demand should be equal. This is the first step. Let us see that. The first thing is that rows, as I said, these are the sources. Example, what we have taken is the biryani outlets, and the columns, the destinations, is the places of demand. And we have taken 4 destinations, and the cell values, cost per unit transporting from the source to the destination, supply values on the right side from the outlets, and the demand from the 4 demand areas they have chosen, which is written in the bottom of the column. Now the first step is that, as I mentioned, the total supply should be equal to total demand. Why? Because there is a demand of 150 orders. If they can't supply 150, we can't solve this problem, and there is no meaning at all. When they have demand, they should also have the capacity to supply. That is why the first step or the first verification that we need to do is that balancing of the problem, whether it is balanced or not. If the total supply is equal to total demand, we can call it as this is a balanced transportation problem. If it is an unbalanced, we need to add a dummy row or column with the 0 transportation cost to balance it. Okay, these are the checkpoints, or these are the checks that you need to do. And the third step is that we need to find the solution by using, we call it as an initial basic feasible solution. What is this initial basic feasible solution? Generally, to solve this transportation problem and to find out the total cost, there are 2 steps involved. The first step is that finding out the IBFS. What is IBFS means? Initial basic feasible solution. This one. To find out the IBFS, we have 3 methods. One is called northwest corner method. Some people may call it as a northwest corner rule. Second one is called least cost method. And least cost method, they call it as a cost matrix method. And this one we call it as a Vogel's approximation method, VAM method. Right? These are the 3 methods we have to get the IBFS, that means initial basic feasible solution. Generally, in VAM method, we will get closer to the optimal solution. Closer to the optimal solution means our aim of transportation problem is to minimize the total transportation cost. Right? Now, in VAM method, you will get a very optimal solution. This is the minimum transportation cost which may occur to deliver from, which will involve in transporting the vehicles from the sources to the destinations. Now, check for the second step. Actually, in the overall thing, this is the 4th step, and for the solution, this is the second step. Solution is that second step is to check for the optimization or the optimality. Optimality means whether we can improve or not. See, by using NWC method, LCM method, by using even the VAM method, we will get some solution, transportation cost. Even to check whether we can decrease further or not, we have the optimality check. We have 2 methods. One is called Modi method. Second one is called the stepping stone method. Right? And with this, these are the by using these 2 steps in the step 3 and step 4, I mean to say the step 1 to find out the IBFS, step 2 is the optimality check. Generally, in many of the problems, they will ask us to find out only the IBFS. In further steps, they will ask you to find out the optimality check by using any of this method.